Hi friends, my name is Ishu and today I'm going to make a video on complex potential in fluid dynamics. So this is my first video. So here we will study what is complex potential. So uh, uh, let W is equal to phi plus I psi. W is a function of phi plus I psi. It is taken as a function of x plus I, which is z. Z is equal to x plus iy. So W is a function of z. W here we wrote W is be taken as a function of z. So W is a function of z. So W is equal to f of z. Then we substituted this value from here to here as phi plus I psi is equal to little camera problem is, let's see, yeah, I hope now it's visible properly. W is a function of z, so W is equal to f of z. W is a function of phi and psi, and it's a complex function, so it constitutes phi plus I psi in this way, means x plus iy form, and z is a function of x plus iy. So we call it as number 1. And now differentiated, partially differentiated, here I'm writing partially differentiate 1 with respect to x and y. We When we'll partially differentiate 1 with respect to x, we'll get this del phi by del x plus I del psi by del x is equal to f dash of x plus iy, because the differentiation of x is 1. So this remain f dash, and the differentiation of x is 1, so no need to write 1. And when we partially differentiated 1 with respect to y, we get this del phi by del y plus I del phi by del psi by del y is equal to f dash x plus iy, and this I, which is in multiplication of y, so this came here. Then we substituted this f dash x plus iy value from 2 to this, let's call it as number 3. So we substituted value of 2 in 3, and then del it became I into I become I square, so I square is equal to -1. So this theory, we open this bracket, so I into this one, and I into I square, so this is -1 into del psi y del x. So this one, and this one is left side is same, we just simply again write it. And this, so here we got, when we equating, let's write it here, what we did, equating real and imaginary parts, we get, what we get is, let's differentiate this, let's equate this with this one, because they are real, first one and this one, they are real. So del phi by del y is equal to minus del psi by del x, and similarly this imaginary with this imaginary, del psi by del y is equal to del phi by del x. So this is known as the Cauchy-Riemann equation, and the equations and the equations and the problems which satisfy this Cauchy-Riemann equation, they are called as the analytic function problems. So W here, W is equal to phi plus I psi. So W is the analytic function of Z, and W is known as the complex potential. And its converse is, if W is the analytic function of Z, here we prove that W is the analytic function of Z, because we need to satisfy first these equations, then we can say that this is the analytic function of Z. So this is the condition for Cauchy-Riemann equation, and thus for the analytic function. So, and if we have given that the W is already an analytic function of Z, then in that case we can directly say that the real part is known as the velocity potential, and the imaginary part of that analytic function is known as the stream function of a rotational two-dimensional motion, because this is the concept of fluid dynamics, and those are for the only for the irrotational motions, irrotational two-dimensional motions. So we are talking about here irrotational two-dimensional motion. So this is all about the complex potential, and I hope you understand what is Cauchy-Riemann equation, what is the analytic function, and how is W is analytic function of Z, and how it is proved, and this how the conditions are they are derived, and what is the converse of this. If W is an analytic function of Z, then what is the converse? This real part is velocity potential and imaginary part is the stream function, and these equations are for the irrotational two-dimensional motion. So this is all about the complex potential, and I hope you like this video of mine. This is a very small video, and please do like this, subscribe and share my channel. This is my very first video, guys. But I'm trying to make some more videos. Thank you so much.